system. In education system, the biggest problem is one human being coming and telling another human being, how many times I should tell you? Still you have not understood that. That's the worst thing in an education system.
If you have a note and pen, do along with me, because here we are obviously not listening stories, but we are discussing something serious business which are going to make a career of yours. So how it will be? First, I'll make for ductile material. Ductile material. For example, mild steel. So how it will be is, this. Okay. Now I'll plot the points. Say this is A, this is B, this is C, this is D, this is E. Now here, this is called as stress, this is strain, right? Here, till A, the point of A is called as EL, that is EL stands for elastic limit. Beyond this, this is called yielding. Up to here it is yielding, but all over after this it is nothing but plastic region, that is this plastic region. A is called as proportionality limit. B is called as higher yield point. I'll discuss what is that. C is called as lower yield point. So basically this B to C is nothing but this is yielding. I'll tell what is that. Then D is called as ultimate stress or ultimate point. And finally E is called as fracture. Okay. What happens here is, to understand this, I will put in this side. Okay. This is strain. Now, see how it happens. I'm sure all of you have seen a UTM machine in your college, that is universal tensile machine. What we do in that machine is, we take a dumbbell shaped material, say this is any material, this is mild steel, let us say this is a mild steel of this size. What we do is, we fix this in two dies, that is upper and lower dies, where this is connected to a machine. Which machine? UTM machine. Now what happened? We keep pressing, there are knobs which will be having loads, that you keep increasing the load. So what happens when you keep increasing the load, the tensile force, that is this force increases from the center of Lederbrand. This will be called as Lederbrand, which I'll be discussing later. Say for example, it is initial. So the body here is this. Okay. Now, what happens when force is given? What happens? Slowly, 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 force is increasing. So even this is going. Means what? When force is more, stress is force by area. Correct or not? When stress is more, force will be more. So here, when you are giving increasing the force in this direction, when you are increasing the force, similarly what happening is slowly and slowly this is increasing, 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 increasing. So say at A, after coming to point A, you have returned back. You have decided that you will return back to 0. When you have returned back, after returning back, what you will do is you will take this dumbbell outside from the UTM machine. When you take the dumbbell outside from the UTM machine, and now if you check the length, you will find after some time the length will come to its original position. When? Till the point A. If the body have come back to its original position, then it is said that it is because of elasticity. So this is applicable till the point A. That is why it is called as elastic limit. The moment if you have given a force and it have crossed A and it have come here, say for example it have come at this point. Now when you remove the load and when you cross check this L, the L will be no more same, it will be increased, it would have been increased because it have crossed the what? It have crossed the elastic limit, correct? So then it reaches to what? B. Now B is a point that is called as higher yield point, correct? B is what? B is called as higher yield point. So we are discussing on B now. So higher yield point is nothing but what happens is higher yield point, basically this is the maximum load at which the deformation starts. Here the deformation will be less. Here actually A to B, the length will be very negligibly small. But to make you understand, I am taking a gap. There will be a deformation, but the actual deformation will counted from B. That is the maximum load that is required where the deformation really starts. That is the dislocation. You know, we have bodies. This body will be having atoms, correct or not? So what happens? This atom, say it shifts here. So this dislocation only happens at B. Because of this dislocation only there is a change in the periphery in the body. So because of this dislocation, the dislocation starts at B. So we can say the maximum load at which the deformation starts is nothing but called as higher yield point. So it goes, but after some time, that is at C, no more maximum load is required. Even at a minimum load, the deformation will continue. So what C says is, this is lower yield point. So lower yield point means, or lower yield stress means the minimum stress that is required to continue the deformation which has started at B. Clear? So that is the basic difference of B and C. Similarly D. D is what? D is called the ultimate stress. That is the stress before the body breaks. What is that? That means this is our body, correct? This is our specimen. So what happens is, this is specimen. By the time it comes D, what will be the condition of this specimen? I'll try to make you understand. The specimen condition will be something this. It would have come like this. It is no more this. Correct? Because of why? Why? Because of the pull in the body. That is because of this force that in UTM machine we are giving. So what happened? It will go on. So these are the lines. Correct? So these lines are called lines of Lederbretts. So what happened? Finally, the point will be created, right? So this will be something like this. It will first like this, then it will go to like this, and finally what will happen? It will be a point. So this point just before breaking is called as
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.